Okay, fellows out there, welcome to lecture 12, module 1 of my video series on Introduction to Data Structures in C. Today we will be talking about control statements. Now, basically, what are control statements? Why are they required? We know that in a normal execution of a program, the execution goes sequentially line after line after line. Okay, so there might be cases or scenarios in which you need to break away from this continuous flow, and you need to take the control to some other statement which is not immediately preceding the statement under execution. So that might happen quite a lot of time. Okay, this is where control statements come to our rescue. Okay, having said that, let us look at what are the control statements available in C and how to basically use them, and under what circumstances do they come to our rescue and can be utilized. Okay, so control statements can be broadly classified into two categories, that is decision making statements and looping statements. Okay, so we look at each of these categories, and then we'll get to know how to use them and what are they. First of all, decision making statements. Okay, so in C we have two basic categories of decision making statements. particular structure. Okay, so normally the variables created from a user defined data types are termed as statement 1 and statement 2 gets executed. Okay, so again take care of the syntax. Okay, concentrate on the syntax. So the syntax is if followed by a logical or a conditional expression, and then we have the block, okay, or the block or the body of the control loop. Okay, then we have the statements which are to be executed once this expression is true. Okay, and that is the end of the body of the conditional loop. Okay, say you have a scenario, say you are writing a algorithm or a code where your task is, say you need to go and you need to check for a particular condition. If that condition is true, you need to do some action, or else you need to continue. Say you are writing an algorithm to look into a variable and see if it is there. Say the variable indicates apples which are available in a store, so you just go there and peep in into the variable if apples are available. If apples are available, you buy it. You say you decrement your variable where you have a money, or which indicates your balance, and then you have another variable which indicates the pile of stock of apples which are there. So you decrease this, and say you buy an apple. So it can be a function, or it can be coded in your main program as well. Okay, so suppose if you want to go and check for this commodity apple, say you write an algorithm or you write a code where you go ask for the apple. Now based on whether it is available or not, you need to take two actions. If it is available, you need to do some functionality so as to buy the apple. If the apples are not available, you carry on with your regular processing. Okay, you continue with your regular routine, whatever is to be done next. Okay, so this is the scenario which you want to code, or which you want to write down as a software. Okay, so in this scenario, obviously the if statements is comes to your rescue. Say if I want to mimic this, you want to check whether a given integer is positive or 0. So say a variable which has an integer value, say indicates the availability of the apples in a store. Say you want to see if it is positive. If it is positive, you need to do some action, or you need to buy it out. Okay, if it is 0, then you basically need to continue with your regular processing. Okay, so I said that is the scenario, and why I need to code this. Okay, so let's see. Here is the piece of code which actually puts this algorithm or this problem statement into action in C language. Okay, so I have my main code, and then I have the variable n, which asks you for the number of apples which are available. Say enter a number, and then you scan this in this variable n. Say you say scanf percentage d ampersand n. Don't forget the ampersand when you use the scanf. Okay, so both printf and scanf, as you remember, are formatted input output. So when you want to read something into a variable, or you want to write something out of the variable, you need to use formatting. So here you need to use percentage d to indicate that, okay, I need to read the input as an integer, and I need to store it in the address pointed by n, or the address of n. Okay, so that is where the ampersand come into. Most of the time the students miss this ampersand out. Okay, for the beginners I'm telling. Okay, so I have the scanf where I read the input into this n and then check. So here is where your if statement comes to your rescue. So I check whether if n is greater than 0, that is if this quantity is positive. Okay, if it is positive, then you print the number is positive and I'm going to buy the apple. So you encompass, or you write your functionality out here. Okay, again, given thing to be noted out here is, since it is just a one liner code, it is not mandatory to have the curly braces. There is no harm in putting it or incorporating it in your code, but it is not mandatory. If the functionality is a one liner like this, so you just have one line of code under the if block. Okay, or the entire if block contains only one line. In that case, putting the curly braces to embark, or to differentiate the body of the to distinguish or to establish the scope of the if loop is not mandatory if it is only one line. Okay, if you have multiple lines, then it is required that you demarcate the body of the if loop, okay, or the if statement with the curly braces. So here it is just a one liner, so uh, without using the curly braces also the task can be accomplished. So if n is positive, then this gets executed. If n is negative or equal to 0, then this gets executed. So I have two ifs, okay, one below the other. Okay, so this is where if comes into picture, and you can basically use the if loop to take a decision. So you have come out here, based on this condition you either branch here or you branch there, or if it is something else, if n is not an integer or it is a null or something like that, you branch out there directly. Okay, so that's what it happens. Okay, so that's the application of if loop. Okay, so that's what it is. If n is 0, this gets executed. If n is less than, or if n is greater than 0, this gets executed. If n is say negative or equal to 0, that comes into picture. Okay, and hope that you have got the concept of the if loop. Okay, then we have the if else statement. Okay, so the if part remains as it is. Okay, only thing that gets added is the else part. Okay, so here you have the same scenario. So you go and ask the vendor for an apple. If there is an apple, you buy the apple. Okay, if this commodity is not available, say your algorithm says that buy something else. Okay, preference should be given to apple, but if apples are not available, at least buy some vegetables or fruits and then continue with the process. Okay, so here if apple is available, buy the apple, else buy something else whichever is available and then continue. Okay, so the vocabulary itself makes it very very clear. So you have a if part, else if condition is not met, then you have the else part. Okay, so that's what happens out here. Say suppose you want to code this scenario. Okay, let's first look at the flow chart of this. Okay, so you have the start, and then you have the test expression, say this one. You test for the expression. So if it is true, this is the body which gets executed. Okay, this is the body which gets executed. Okay, else if it is false, this is the body that gets executed. So that's the body that gets executed out there. Okay, the difference between the flowchart of a if and a if else is, in a if else you have this body, in a if statement this body is not there. Okay, so this directly gets connected out here. Okay, this is not there. So that's the only difference in the flowchart of a if and a if else. In a if else, when there is a false, you have some other conditions to run, whereas in a if you just continue with the normal execution. So that's the difference between the if and if else. Okay, say for example, let's look at a scenario where you need to solve where you can use a if else kind of a thing. Okay, suppose you have been asked to write a program to solve a second order solve the second order quadratic equation, say ax square plus bx plus c is equal to 0, and you need to find out the roots of this equation. Okay, so we will simplify this, because the main task is to know how the functionality of if else functioning, not to solve the equation. So I've just simplified this, saying that if the discriminant part is negative, then there is no answer. In fact, in your mathematics lecture might have told you, in this scenario you will have a complex output, complex roots. Okay, so out here I have said that, okay, if the discriminant part is 0, then the real roots doesn't the output is not real, it's complex. So in other words, I'm saying that there is no answer. Okay, there's no real answer. Okay, it's a complex answer. Then comes the other scenarios. If the discriminant is greater than 0, then you have two roots. If the discriminant is 0, then you have this equation. So depending on the value of discriminant part, what is the discriminant part? It is just square root of b square plus b square minus 4ac. So this is the discriminant. Okay, so if the discriminant is greater than 0 or positive, then you have two roots given by these equations. Okay, you have two roots given by these equations. If the discriminant is 0, you have one root or two roots of equal values given by this equation. And the discriminant, if the discriminant is negative or less than 0, then I say that there is no answer. So that is the scenario that I want to code. Okay, I want to code in C. Okay, so let's look into how it has been done. Okay, so I have my main function. Concentrate on the use of if else block. Okay, I have the main function, then I have a variable to store my discriminant, that is delta, then I have to store my um, I have variables to store the value of a, b and c. Okay, those are the indices or values of the variables. Then I have two more variables, x1 and x2, to store the roots, okay, of this equation. So these three are to basically store the equation, and these two are to store the roots of the equation. Okay, so then I ask the user for a, b, c, and then I read them. Okay, I assume them all of them are floating, so I read them, and then I calculate the delta value or the discriminant part. Okay, so now I have the delta value or the discriminant value, and based on this value I need to take a decision now. So if this value is greater than 0, I need to do something. If it is lesser than 0, I need to do something, and if it is equal to 0, I need to do something else. Okay, so I have three conditions. Okay, and I need to check just one of them. It's not that I want to execute, I want to calculate all the three. I just need to calculate one based on the value of the delta. Okay, so I first check if delta is smaller than 0. So this is the easiest part. Okay, so if delta is smaller than 0, then print up the equation has no answer. That is basically you are taking care of this part. If the delta value for the given abc was lesser than 0, you just need to do this, and then you come out of the control loop and carry on with your regular execution. Okay, so that's it. Okay, now if this is not true, and delta is not smaller than 0, or it is not negative, okay, then I need to check the next condition. Okay, that is else if. Okay, is delta equal to 0? Now if delta is equal to 0, you just need to calculate this. So I calculate x1 is equal to minus b divided by 2a, and then I say x1 and x2 are both equivalent to that value. Okay, so that is what happens in this block of code. Fine. Okay, now if both of them are not true and delta value is positive, okay, then I actually need not check. So since this is false, since this is false and this is false, this should be true. So I need not put another if there. You can do that as well, but not required. So logically it doesn't make sense. Okay, so directly then, if the first two cases are not true, then the third one should be true, or the third one does exist by default. Okay, so I am not basically checking for this at all. I am presuming that since these two are false, this has to be true. Okay, and then that is been put in the else block. So in the else block I have coded out this part of the algorithm, and that is how it works. Okay, so those are the three blocks that come into picture with respect to if else. Okay, so now you can see, based on the value of delta, you either branch here, or you branch there, or you branch there. So you have a control over which block of code needs to be executed once you calculate delta. So once you know delta, depending on the value of delta, you either branch to this block or this block or that block. Fine. So that's what the control flow of if else is. Okay, so that I think pretty much makes things clear to you. Okay, then we'll have the switch. Okay, so this thing of the flow of switch is very similar to that of if else statement. Okay, here I have an expression. I check for the value of a particular value, which is the output of this expression, or a variable. It could have been a simple variable x as well. Okay, and if that particular case is met, then you basically execute that particular block of code, and then you continue. Okay, so if this is met, you execute this block of code, and then you continue with the rest of the flow. If this is not met, then you check for this and this, and if nothing is met, then the default block gets executed, and then you continue with the flow. Okay, so that what happens. So first you check for case 1. If case 1 is true, execute this. If it is false, check for case 2. If that is true, execute this. If not, check for case 3. If that is true, execute this. If neither of these cases are true, then you basically execute the default block and continue with the regular flow of the expression. Okay, so that's how a switch statement works. Okay, so it's basically just like if else if, it's a multiple branching statement. Okay, so that was all about the control statements in C. Now we'll have a look into the looping statements. Okay, the decision making statements where you actually have a loop. So unlike the control statements, in looping statements you are used to execute a block of code over and over again. Okay, so this basically helps you to write a code which has which is more optimized. Okay, so you need not repeat yourself over and over again. The loop basically does it for you. It repeats the block as many times as you want, depending on which looping statement you use, so that you need not code it over and over. Okay, so basically in C we have two blocks of looping statement. First thing is the entry controlled looping statement, and then the exit control. In the entry control looping statements we have the for loop. Okay, and then we have the while loop. Okay, look at the syntax of for loop. The for loop basically follows the syntax just like a if, but instead of a if I have a for. Okay, and since it is a looping statement, it basically uses a kind of a variable which acts like a counter. Okay, it uses a variable which acts like a counter. So basically, what is the initial value of the counter? What should be the exit value of the counter? What value should I exit out, and how should the counter be updated? So basically a for loop has three parts: the initialization, the condition, and the updation. Okay, so it is not mandatory to have any one of this, or in fact either of this. Okay, so it is not mandatory that you have the initialization. Okay, so you can leave it blank as well. So we'll come to that at a later part, but in a normal scenario I do have a initialization part. I have an initial condition, then I have an exit condition, and then I have a updation rule for the counter variable, how the counter variable needs to be updated. Okay, and then I have the body of the for loop. Okay, or the scope of the for loop. So this is the scope of the for loop, demarcated with the curly braces. Okay, so since the condition of the counter is being checked at the entry of the block or the scope, it is called as entry control. So if this condition, if the initialization condition itself, if the exit condition itself is met when you basically enter this loop, then the loop basically comes out just like that. It doesn't get executed at all. Okay, so depending on that, the condition is being checked at the entry point, so it's called as the entry control statement. Okay, so very similar to, so for loops are used basically when you want to do a task for a very specific amount of time. Say you want to run this block of code say for 5 times. Okay, so I can initialize the counter variable to 0 to 4, and the updation rule will be say incremented by 1. Okay, so 0 1 2 3 4, so for 5 times, so this gets executed. So when you are very sure, and when the looping is specific to say a particular amount of time that it needs to be done, then we basically go for for loop. Unlike for loop, in while loop what happens is, again it's a looping statement, but in a while loop I check for a condition. So very similar to the if, but in if the block gets executed only once and then you come out of the block. Whereas in a while loop the condition is checked, and if it is true you enter the block or the scope of the while loop, and you keep into it, looping into it till this condition is true. Okay, the moment that this condition becomes false, you come out of the for loop, or sorry, the while loop. Okay, so that's the difference. Okay, so make sure that you are using some expression or a variable out here which does it change its state in this block of code. If it doesn't change its state and you enter this block and this variable or the expression output doesn't change based on the execution of this loop or this block of code, then you are stuck in an infinite loop. This goes on forever. Okay, but that's why I say make sure that whatever variable that you pass or the expression that you write out here does change when this block of code gets executed. Okay, and based on the change that happens in this block, you look in for the new condition of the variable or the expression, and then you decide whether I need to continue with this block of code or not. Okay, so that's what happens with the while loop. Fine. Those were the two entry control statements, the for loop and the while loop. Okay, because the condition are checked when you enter the block of code. Okay, unlike that we have the do while loop. So in the do while loop is exit control, that is this block of code is guaranteed to execute once. So one time execution is guaranteed. So you enter this and then you just execute the block, and after that you check for the condition. So if the condition is true, you loop back again and keep in this loop till this condition becomes false. So the moment this condition becomes false, then you exit out of the loop. Since you are checking for the condition at the exit point, this is called as exit controlled looping statement. Okay, so it's very similar to the while loop, but instead of checking the condition at the beginning, you are checking the condition at the end. So execution of this block one time, okay, that is one time execution of this block is guaranteed. Fine. So let's look into the syntax of for loop. Okay, so I have the initial state of the initialization of the variable, then I have the exit condition which is stacked, and then I have the iteration status, or the way in which the variable needs to be incremented, okay, or the counter variable needs to be incremented, and then I have the body of the for loop. Okay, so that's about the syntax. So for, okay. So let's look into an example of for loop. So here I have the main, then I have a, which is my counter variable, then I say initial condition of a is 1, and the exit condition is execute a till a is lesser or equal to 5. Okay, so the moment a becomes 6, you come out of this loop, and the way in which a gets incremented is plus plus. So every time a gets incremented by 1, the moment this loop gets executed. And what does the loop do? It just prints out a. So the output of this would be very obvious. Okay, it will be 1, 2, 3, 4 and 5. The moment a becomes 6, this condition is satisfied and you exit out of the loop. Okay, so that's how a for loop is written. Okay, and this is how a while loop is written. Again, while condition, till the condition is true, you keep looping. The moment the condition becomes false, you come out of the loop. Okay, so this is the example of a while loop. So again, I have my main function, then I have a variable whose condition or whose value is checked, and now the same thing can be mimicked using a while loop. Mind you, for loop and while loop are interchangeable. Okay, so but you use it as per your convenience, whichever you are comfortable with, or in fact whichever makes the code more readable and more legible to any given programmer. So you use that particular looping statement. So the same scenario is been mimicked using a while loop out here. Okay, so I have a variable a whose condition is checked. So during this point, if the value of a is greater or lesser or equal to 5, I keep looping. The moment it comes out, it becomes greater than 5, then I come out. So I have the printf, and as I said, make sure this particular variable changes its state. So if I have just a printf statement, this variable is never going to change. But unlike the for loop, I don't have this iter condition inside this while loop. So I have to do it in another separate line of code. So that is what I'm doing out here. Okay, so a gets incremented. So and next time when it comes, it gets incremented. The condition is checked. So as long as a is lesser or equal to 5, I am in this loop. The moment a becomes 6, I come out of this loop. Okay, again, as expected, the output of the loop is very similar to that of the previous one. It just prints out 1, 2, 3, 4, 5. Okay, so that's what is the output of this. Now that is the syntax of a do while loop. So this is the syntax of a do while loop. So I have do, but I have while at the end. Okay, so one time execution is guaranteed. Okay, so here look at this piece of code. So I have main, and then I have a do while. So printf, if display is display once. So while 2 is smaller than 1 is while 2 is greater than 1. So this is a false condition. Even though this is a false condition, this does get executed once. So one time execution is guaranteed. So the output of this will be I will be displayed once. So that message gets printed out loud and clear when you execute this line of code. Okay, hope that it makes sense and the concept is clear to you. Okay, then here is an example of a nested for loop. So I have a for loop out here. Okay, for a, using the counter variable a, then I have another for loop inside it. So you can basically nest one loop inside another. Okay, it's not necessary that you nest for loop inside a for loop. You can have a while loop inside a for loop inside a while loop, and so on. Okay, so you can basically nest any of the control statements one inside the other based on the logic that you want to implement. Okay, so in this particular scenario I have two loops. Okay, one nested inside the other. One loop goes from 1 to 5, the other loop goes from again 1 to 5. Okay, and I'm printing out the value of b. So as expected, what happens out here is the value of b 1 2 3 4 5 gets printed out 5 times. Okay, so this gets executed, then you go to the next line, and again you come back, and again you execute, again you come back. So this loop gets executed 5 times. So you basically print 1 2 3 4 5 5 times. Okay, and so on. Okay, so that is the output. I hope you get the logic out there. Okay, so that's what you can basically nest one loop inside another. Okay, you can nest a do while loop as well. Okay, so I'm the outer loop, and then you write this, and basically you execute this. Okay, so is 1 greater than 10? No, it's not. Is 2 greater than 10? No, it's not. So basically you enter this loop, you print this, then you enter this, you print that, you come out here, you see this is not true, so you come out of the innermost loop which is in yellow, then you come out here, then you come out, you see that this condition is also not true, then you come out of the outer loop which is in blue, and then you execute. Then you execute the rest of the lines. Okay, if there are any. In this case there are none. Fine. So that is what happens, and basically you print out I am in the inner do while loop one time. So that is the output of this particular piece of code. Okay, that's all for today, folks. Thank you for staying with me. Hope the concepts of control statements are clear. If not so, then you can go through my handouts given in this lecture course and basically post me any questions that you have. I'll be very glad and happy to answer it out. Okay, and stay tuned with me for my next lecture. Thank you.